Hi, I'm Natalie. I am a tech lead for public sector at Chainguard, and I'm a field engineer. As noted kind of earlier, we use Sigstore a lot. So much so that you actually have to filter out us in order to get meaningful data for everyone else using the public good instance of Sigstore. As a field engineer, though, this means I'm not actually interfacing with engineering internal to Chainguard much at all. I'm actually mostly talking to end users about what Sigstore is, how it works, what it can and can't answer for you, where it fits into your organization's threat model, and mostly answering a ton of user friction points. And I see a handful around this one big thing, and that's multi-architecture containers. I've been at Chainguard for 1.5 years, so I have been on a ARM-based Mac for 1.5 years. Swapping between architectures as needed, but mostly not. And this right here just feels like magic. Like I can just pull Python, pull Ruby, pull whatever, and the architecture that I need magically appears, like I don't have to specify it. However, that's not magic. It's just a lovely default that's not seen for you. You can specify -- platform or something else to get the right platform that you're really wanting. The thing is, the folks I need actually end up doing something like this. They build or buy a MirrorBot 9000. And this MirrorBot is supposed to grab all of the things, do some sort of magic safety checks. It's going to scan it with vuln scanners and antivirus, and it's going to do verifications and SBOMs and build attestations. It's going to grab all the things. We are going to sprinkle magic compliance pixie dust on it, typically by messing with the SSL certificates, and so on. So that the folks that are actually using this software, it's not upstream directly, it's upstream maybe plus some changes with the SSL certs or pointing to an internal package repo, etc. But this level of control actually kind of messes with how folks are thinking about Sigstore. Because once you are on this other side of this MirrorBot 9000, that image isn't the same, so of course that verification's not going to work. And yes, you can say, and a lot of folks do, that like I bought this tool from some vendor that magically does all of this for me, and that doesn't alleviate the burden of responsibility to know how that thing works. In a single architecture world, this was really, really simple. There's a manifest, defines all the blobs in the image, and we just signed that manifest at that SHA or that tag. This is how that looks like in a tree, and all of our ingest scripts, all the things that just pulled all the things and did all the things and put it somewhere else, just worked. Because it looks a lot like this. And a no annotations example, so something that looks a lot like this, is oh my goodness, did I just break my, yes I did. Cool beans, we're gonna wing it from here. Boom, doing it live, absolutely. This is gonna be kind of awkward, but this is roughly what that looks like. So there's a config, and all of these are JSON and tarballs all the way down. But this is really awkward, and I can't actually see anything over there. So I'm going to have to go back to slideshow mode. That is literally the worst. Start. Cool. But that probably doesn't hold up to shell scripting, because in order to make a multi-architecture image, what you end up with is a lot more like this. Python is a little scary because there's like 10 different architectures it's built for. So here's what this looks like at 2, and you can just add more colors of these things. So when you run, pull an example image, you'll get that manifest of manifests, and then go, oh, hey, I only need the x86 binaries, so I'm going to pull only the things over here in the green. So pop quiz. Where does Cosign sign? I promise I will not identify any of you or ask for your names. Repo? OK. Recor? No, I meant where on the diagram, sorry. Yeah, where on this thing does Cosign sign? When you say Cosign sign the image, what happens? Like what here is getting validated? Okay, tell me both. What happens or what should happen?
Well, it should sign the highest level thing that has the hashes of everything else. It does do
That is exactly correct. By default, it signs up here this, I can't even point on here. Oh my God, this is going to drive me nuts. This manifest of manifests. That is correct. However, it can sign just these manifests down here. And this is super common if you are having a build that is on different computers and they're all latest, and then you have to reassemble this manifest of manifests up top. That is not magically done for you. And most of the time, the image manifests are it's not magic. You just have to have an extra step to reassemble this. And most of these high-side ingestion problems come from not understanding how you're signing things. And these annotations, of course, can be all the different things. And more importantly, the reason that it always signs the highest level by default is if you mess with literally anything under that, that highest level changes. Let's look at an example. Here is a big gnarly query for URL for GitHub to look at manifests that would be signed. We're going to use this repo because it's on the front page, and I'm not that mad at it. So I'm going to try to drag this terminal session over, and it is not coming. I'm very sad. So we're going to go ahead and escape out of this, maybe, and it'll let me do that. Maybe it will not. Boom. Haha. Cool. The perils of window management. All right, so here's that Cosign verify, and notice we're looking at main. It's going to give me this big gnarly thing here in the terminal, which I have handy dandy copy pasted into JQ. Boom. All right, so here is that whole manifest. Whoa, this is terrible. All right. So what I'm looking for in specific, though, because in this case, they signed the tag at main. That is a mutable tag. So we want to figure out what SHA that is, and here that is over here. And if I go over here, because we're going to make this a GUI because life is easy, this is the right one. And I click over here, this SHA sum should match the exact 3 SHAs that it printed out on JQ. And that is how we know main at this point in time refers to this, and it all got signed. Because if I run the next thing with that SHA, I will get the same valid verification signature. Again, there's no magic here. It's all SHA sums. However, understanding that that extra manifest layer exists is kind of hard for all of our scripts. So I'm going to go back to slides real fast. Slideshow. Do the thing. Awesome. So, whoa, how did you know what things to verify? Because that kind of big query, or that big long command, is not very friendly. More importantly, there's 2 kind of things here that to understand. There's the OIDC issuer and the identity. So in our case, this was the identity of that GitHub Actions workflow. By and large, on the public side of the internet, you're going to be dealing with GitHub here. So this is the right identity to look for. But in your repo, whatever you're ingesting, this is going to change. The repo is going to change. Here's an example of how to do that in GitHub Actions. You can do this with Builda, Docker, KO, etc. It's bash in YAML. All CI systems on some level, I think, are still bash in YAML. Here's another example. It's echoing, it's just that last line, echo your tags into xargs and run Cosign sign. However, going back to public sector, the ratio actually flips between GitHub and GitLab. Here's what this looks like in GitLab. Again, it is bash piped to YAML, or bash in YAML. And we're again going back to here, this Cosign sign image digest right here at the very bottom. So we wrote some scripts to do all of this verification and validation and ingestion for several architectures. And what that looked like is we Docker pull thing, do whatever scanning and verification and magic compliance sprinkles. You retagged it and you pushed it to internal. And this started to break at multi-architecture because the first MirrorBot 9000 did not look like this. And so we ended up revising these scripts. So you're going to cosign verify, and then for that platform and list of platforms that you need, you're going to pull, scan, do whatever you need to do, retag it, push it internal. And then I would recommend creating a new multi-architecture manifest on your internal registry just to preserve the magic of not having to think about your architecture. However, the early internal mirrors didn't really support multi-architecture that well, so Python latest became latest-AMD64, ARM64, et cetera, on your internal network. It's not great, but on the other hand, it is explicit, like extremely explicit. You can't mess this up. And it may be more effort than it's worth to really change everything over, assuming that you have that tag and architecture naming convention in place. Handy dandy little bit of shell script here to print out a list of manifests. So again, it's JQ piping to sort and unique. And then my last little tidbit here is offline verification isn't usually what you want. When you have an artifact signed with OIDC, all of the information needed to verify that without connectivity to Recor exists on the image, so long as you move the tough root over as well, which is a very simple process. However, because you are changing the image when you are ingesting that image, that actually doesn't do what you think it does. So verify down here, bring it in, do whatever you need on the high side. And self-hosting Sigstore gets a bad rap for being incredibly difficult. It's not, it's doable. It's not simple, but it's doable. In the real world, doing this at scale means knowing what software you're using, how that software is built, where it's being signed, and verifying it in that MirrorBot 9000 before you bring it in. Turns out software supply chain security is a lot of inventory. Inventory is hard work, even when it feels like magic. TLDR, it depends on the upstream project. Adjust your processes accordingly. If I had one ask, most users that I work with do not understand what Sigstore is at all. So having that copy-paste command for cosign verify, even if you're not explaining in depth what Sigstore is, what it's doing, where it fits in your threat model, like that's the same thing as giving someone a copy-paste, curl the SHA-SUM and pipe it to the command to generate the SHA of that artifact. But most importantly, whether you're on the maintainer side or the user side, or most of us in both, don't trust a magic black box. Look inside it to sleep soundly at night. And here's where to find me.